Question 4.3. Determine the equation of the perpendicular bisector of AAB in the form y equals mx plus c. This perpendicular bisector will then be CE. From Theorem 1 of Euclidean geometry. Line drawn from the center of circle to the chord bisects the chord and is also perpendicular to the chord.
Firstly things first, since we know that CE is perpendicular to AAB, we have to find the gradient of the perpendicular bisector. The product of the gradient of each line is equal to -1.
Now using the gradient formula, we are going to calculate the gradient of AAB. Y of AA is 1 minus y of B is -3, giving us for all over x of AA as 5 minus x of B as -3, giving us 8,
which is equal to 1/2.
Therefore, gradient of AAB times gradient of CE equal to -1. Since we know that CE is the perpendicular bisector of AAB,
and the gradient of AAB as 1/2 times m2 equals -1. Therefore, the gradient of the perpendicular bisector will then be -2. Since we know the gradient of the perpendicular bisector given as m2, we will then ask the coordinates of E as 1 and -1 lying on the line CE to find the constant C.
Giving us -1 equals -2 times 1 plus c. Therefore, c is equal to 1. Therefore, the equation of the perpendicular bisector is y equals -2, x plus 1.